All right, this is 1.3 Day 3 notes. I'm Mr. Bishop, and today we're going to talk about linear functions. Okay, so what are some big things we know about linear functions? The first one, the graph makes a line. So for linear functions, we know the formula. It has a slope, it has an intercept, and those are characteristics of a line. The other thing we know for sure is it has a constant rate of change. And remember, rate of change is really just a fancy way to say slope. So it has a constant slope. So what is that in particular? The slope between any 2 points on the graph. Any two. Pick any 2 points on the line, find the slope between those 2 points, and it's going to be the same, no matter which pair of points you pick. So that's what it means to have a constant rate of change for our linear functions. So we know the graphs look like a line. We have a constant rate of change between any 2 points on the graph. And the other things you know about lines, they have a slope and they have an intercept, a y-intercept, we call it. Let's sketch a really simple graph. So quadrant 1 here, I got an x-axis, a y-axis, a few tick marks here, 1, 2, 3, 4 tick marks there. And then I'm going to add a few points to this. So at 0, 0, I'm going to put a point, I'm going to call it A. And then at 1, 2, I'm going to put another point, I'm going to call that B. And then over here at 2, 4, I'm going to put another point, call it C, and I'm going to draw a line through those points. So we know the coordinates for these points. First I want you to look at, if we go from A to B. So from A to B, I put some dotted marks on here. It looks like you go up 2 and then over 1. And that's actually a pretty clear way to write the slope. Up 2 over 1, rise over run. And then if we go from, let's say, A to C, we would be going up 4 this way. And then this way we'd move 2, so that'd be up 4 over 2. So even if you pick A and B, the slope between A and B, well, it's up 2 over 1, right? So 2 over 1 is just 2. Or if you were to pick A to C. So if you pick A and C, what would the slope be? Well, in this case, it'd be up 4 over 2, the rise over the run. But even if we do that, 4 over 2, that just simplifies to 2. So that kind of proves our point here. If it's a line, you can pick any 2 pair of points, the slope's going to be the same. And we know M stands for slope. If you don't remember, let's recall slope-intercept form. So it has something to do with M, the slope, but it also has something to do with the y-intercept, hence the name slope-intercept. That's y equals mx plus b. So M is the slope, b would be the y-intercept. And then x and y, those can change. Those are just points on the graph. All right, so let's look at the first example here, example 1. So we're going to start with just a table of values. Notice I got 3 columns going here, column 1, column 2, column 3. And for each of those columns, I want the first one to be x, the second one can be f of x. Remember, that used to be y, but now in pre-calc we call it f of x for the outputs. So I got the inputs, I got the outputs, and this you should recognize from the first day. This is going to be slope. Change in the f of x over change in the x. Or on the first day we said change in y over change in x. So we have our points here, and then we're going to find the slope between those points in this column. And for my x values, I'm going to pick some easy numbers here. How about 5, 10, 15, 20? Those will be my inputs. And then the outputs that go with those, 2, 6, 10, and 14. So I didn't give you a formula for this function. I didn't give you a graph. All you've got is a table. And really I want to know, is this a linear function? So you've got 1, 2, 3, 4 points here. Is this going to be a linear function? Well, if we can just find the slope between consecutive points, and it turns out they're all the same, then that proves that this is in fact a linear function. So let's look at the first 2 points here. We got 5, 2, and 10, 6. Think of those as just coordinate points that you could graph. And in this column, we're going to find the slope between those 2 points. So let's look at the first 2 points. Remember, on top of the fraction, we would have to subtract the y's. So on top, let's go 6 minus 2. That'd be 4. And on bottom, let's subtract the x's. So 10 minus 5, that'd be 5. So the slope for that point between these 2 points would be 4 over 5. All right, let's move down the line then and look at the next pair of points together. So now we've got 10, 6 and 15, 10, those 2 points. So on top, I'll subtract the y's again. So 10 minus 6, that gives me 4. And on bottom, subtract the x's, 15 minus 10, there's your 5. So far, so good. The slopes match between those 2 consecutive pairs of points. All right, and then we have the last pair here, 15, 10, and 20, 14. So on top, I'd have to subtract the y's. So here are the y's, 14 minus 10, that gets me to 4. And then if I subtract the x's, 20 minus 5, there we go. So we have the same slope between each consecutive pair of points. What does that prove? This is indeed a linear function. Fantastic. So now we know how to prove if things are linear, or if we'd gotten one that was a little off, we'd know right away it's not linear, just from a table. Let's look at example 2 here. A little bit of a word problem, different scenario. So the cost of a divvy bike in Chicago can be represented by the formula, and I'm going to give you the formula. Now it's sort of similar to how divvy bike works. It's not exact, but kind of simplify it so we can work with this problem. So I'm going to use c of t, it's a function, c of t equals 7 plus 2t. So you can probably guess what t stands for, the input, and then what the output c of t stands for. So where c of t is going to be the actual cost at the end of the day in dollars, and t is going to be the time, and that's measured in minutes. Actually, excuse me, that's measured in hours for this example. Again, a lot of times the data and formulas I use are true. This one's not exactly true, but it's similar. So we're going to use it in this case. It works for us. So I actually don't have any question about the math necessarily. There's nothing I need to see you plug in and do for this problem. What I need to see you do that's new for pre-calculus, that you probably didn't do as much in Algebra 2, I need you to be able to identify and interpret a few things. Starting with, in this case, the slope. So this is definitely a linear function. I need you to identify the slope and then tell me what it means in the context of this problem. Well, the slope is typically the number on our variable, so it's definitely 2 in this case. So m equals 2. What the heck does that mean? It has something to do with divvy bikes, I got that. Maybe an easier way for you to think about it would be 2, you can write that as 2 over 1. And since this function tells us about the cost of a divvy bike, it looks like the longer we ride it, it's like 2t, right? So for every additional hour we ride it, it charges us $2 for that amount. So let's convert it to units here. 2 over 1, and we're riding this divvy bike. 2 would be dollars, and 1 would be the time, or hours. So $2 for every hour. So how do we interpret that? Well, the longer we ride this thing, the more we have to pay. So we can start by saying, for every additional hour the bike is rented, right? For every additional hour that the bike is rented, the cost increases by $2. So we actually do this a lot in AP Stats too. You have this linear equation. You have to interpret what the slope means. And I always teach my students to say, for each additional unit in blank, whatever the x or independent variable is, for each additional unit in that, you can expect an increase or a decrease by whatever this slope amount is. So for each additional unit of blank, we can expect an increase or a decrease of blank. Okay, that was for slope. Part B, you can probably guess. I want to hear from you on the y-intercept. So can you identify that value and then interpret it? Well, it's the only other number up there, right? That would be the 7. That would be our y-intercept. So B equals 7. Hope you guys are okay with me calling it B. Just like when we did y equals mx plus b earlier, that's going to be our y-intercept. And so the y-intercept in this case, it really doesn't care how long you ride the bike. Pretty much you had to pay $7 to even get it out of the rental storage. So whether you spend 0 minutes on it or 100 minutes on it, you've got to pay that $7 flat rate. So even if you don't ride the bike at all, just to check it out, you've got to pay the $7 flat fee. So we can say to rent the bike, there's a $7 flat fee on top of any of the time charges. So that one really isn't affected at all by the time charges. You just have to pay a $7 flat rate just to get on the bike. And again, not true for Divvy bikes, not the exact formula. I'm sure you could probably come up with a better one, but works well for this example. All right, let's go to example 3 here. Little different scenario for example 3. So it says a car that costs $19,200 in 2008 is depreciating at a rate of $2,500 per year, which means it's losing value. At $2,500 per year, that's the rate it's losing value at. So we don't have a formula yet, and that's actually the question I'm going to ask you. So the next piece here, I want you to write a formula for the value V of the car T years after 2008. So we're not using X and Y in this example, although we can start with using those because sometimes kids they relate to those better, a little bit easier. In this case, we're going to use V and T when we get done, though. So hopefully it's a linear function, since we've been talking about that this entire time. This initial value, $19,200, apparently that's what it is in 08, but from there it just decreases. It gets lower and lower and lower. So why don't we start with what's the y-intercept? It's definitely not the $2,500 per year. You can think of that as a rate of change. That's the slope. The y-intercept would be this initial amount that's fixed. It's unchanged. So that would be the 19,200. That's our starting point, our y-intercept. So that we can think of as being like our initial value. And then for the slope, well, that's got to be the other number, right? The rate of change, $2,500 per year. So M equals $2,500 per year. And I want you to note that this has definitely got to be a negative value because it's depreciating. So if you put plus 2,500t, that'd be off. That'd be like adding value to the car. So let's make sure that this slope is negative when we go ahead and write it. So $2,500 per year, and it's going to have to be negative when we put in our formula. So if we just use x's and y's, it should look something like this. Y equals negative 2,500x, that's the slope on the x, plus our y-intercept of 19,200. Now, all the heavy lifting is done, the hard stuff is done. Now, let's just make sure and get the variables correct here. So, the value v, that should be y, right? This thing computes, the output should be the value. So that should be v, where y is. And then t years after 2008, that's the independent variable, right? Time. So t is going to go where x is. So just to be sure and correct here, the value v instead of y equals negative 2,500 t instead of x plus 19,200. There we go. Or if you wanted to represent this in function notation, I'd be totally fine if you said v of t, right? Instead of just v. V of t would be okay in this case too. Meaning you plug in t, the output is v of t. I'd accept either one. But for now, let's go ahead and just focus on this one. V equals negative 2500t plus this 19,200 value. Okay, last question here, a little bit of a follow-up. So how much would the car be worth in, say, 2015? And here's the biggest mistake I see kids make. They're like, oh, 2015, no problem, Mr. Bishop. I'll just take that number and throw it in there for t. Totally incorrect, though, right? T, and we need to note this, t is the years after 2008. So if we're in 2015, that wouldn't be the right answer to just plug in 2015, right? 2015 is how many years after 2008. So if you find the difference there, that would be 7. So if you plugged in 7 for t, then we'd be in business. So to calculate this correctly, make sure you're putting 7 in for that t value. All right, so negative 2,500 times 7, that gives us negative 17,500 plus that 19,200 still hanging out there for a grand total of $1,700 in 2015. Wow, that thing really depreciated its value in 7 years. All right, so we talked about linear functions, we looked at them graphically through word problems, and we learned how to interpret slope and y-intercept. That is all for these notes. I'll see you in class.